before there were dinosaurs, before mammals took their first trembling steps across the mud, the Earth was already ruled by wings. Picture a world 300 million years ago. The air is thick, heavy with oxygen. Giant ferns and towering trees cover endless swamps. Strange sounds echo through the mist, the hiss of unseen creatures, the ripple of dragonfly wings that shimmer like stained glass under a dim orange sky. And then, a shadow passes overhead, enormous, alien, and alive. It isn't a bird. It isn't even a reptile. It's Meganeura, a dragonfly the size of a hawk, its wings stretching nearly a meter across. The first true king of the air. In this forgotten age, the Carboniferous period, insects were not the tiny, fragile creatures we brush away today. They were titans. Giant millipedes as long as cars crawled through the forests. Scorpions the size of dogs lurked in the shadows. And above it all, the winged hunters reigned supreme. They ruled not through intelligence or cunning, but through the chemistry of the planet itself. The world breathed differently then. Oxygen levels were nearly twice what they are today. Every breath was richer, every fire burned brighter, and every living thing grew larger than nature would ever allow again. But power always comes with a price. These colossal insects were born from perfect balance, a balance so delicate that when Earth's atmosphere changed, their empire crumbled. Their story is written in stone, fossil wings, delicate veins preserved like ancient blueprints. Each fossil whispers a fragment of their forgotten kingdom, a time when creatures with no bones became the first to conquer the sky. And yet, one haunting question remains. If the right conditions returned, if our planet once again breathed as it did in the age of giants, could such creatures rise again? The answer lies buried beneath layers of time, waiting for us to uncover. To understand how the world of giant insects came to be, we have to travel back, far beyond the dinosaurs, into the heart of the Carboniferous period, around 359 to 299 million years ago. It was an age of swamps, storms, and forests that never slept. The continents were still forming, colliding, and tearing apart. Vast tropical wetlands stretched across what is now North America and Europe, covered in dense forests of giant club mosses, horsetails, and tree ferns that could rise over 30 meters tall. The ground was soft with peat, and the air shimmered with humidity. It was here that the first great experiment in flight began. The atmosphere itself was extraordinary. Oxygen levels reached nearly 35%, compared to just 21% today. Fire could spread easily. Lightning strikes could turn entire forests into roaring infernos. But it also meant that every living creature breathed in a world supercharged with life. Insects, whose bodies rely on passive oxygen diffusion through tiny tubes called tracheae, suddenly found themselves in paradise. With so much oxygen available, their bodies could grow to massive proportions without suffocating. That single environmental factor changed everything. In this high-oxygen world, the first forests formed Earth's earliest complex ecosystems. Fallen trees piled up in swampy waters and were slowly buried, forming the vast coal deposits we mine today, hence the name Carboniferous. Among those forests crawled and flew the first real masters of air and land. Fossil records reveal that Meganeura moni, the most famous of these ancient insects, had a wingspan of up to 70 centimeters. Its fossilized remains, discovered in France in the late 19th century, became an icon of deep time, proof that the skies once belonged to creatures with compound eyes and chitin armor. But Meganeura wasn't alone. The forest teemed with other giants. Arthropleura, A millipede up to 2.5 meters long, slithered through the undergrowth like a living log. Pulmonoscorpius, a scorpion as large as a cat, hunted in damp shadows. Palaeodictyoptera, ancient ancestors of modern mayflies, hovered over the swamp waters, their long tails flickering in the gloom like primitive kites. It was a world where the air itself was a battlefield. Predators like Meganeura would patrol the skies, scanning with their enormous multifaceted eyes, swooping down on unsuspecting prey. Their wings, delicate yet strong, were masterpieces of natural engineering, able to twist and tilt for incredible maneuverability. Long before birds or bats evolved, these insects had already solved the problem of powered flight. Scientists studying these fossils have uncovered microscopic traces of the wing membranes, showing a network of veins that distributed air and strengthened their structure, a design so efficient that it inspired modern aerodynamics. Every beat of their wings was an echo of the first aerial revolution in Earth's history. But what made this period truly remarkable wasn't just their size, it was their dominance. In an ecosystem still struggling to find balance, insects filled almost every niche. They were the decomposers, the predators, and even the pollinators. Though flowering plants had not yet appeared, they interacted with early seed ferns in complex, symbiotic ways. Each species was a small miracle of adaptation. Some could glide, others could leap or dive underwater to hunt. And some, like the giant dragonflies, became apex predators in a world where vertebrates were still small, slow, and confined to the swamps. For nearly 60 million years, insects were the uncontested rulers of the Earth's skies. Theirs was the first true empire of flight, an age before feathers, before warm-blooded creatures, before anything even dreamed of wings made of bone. And yet, as every empire in history eventually learns, power never lasts forever. Something was waiting on the horizon. Something that would change the air, the land, and every living thing on the planet. The fall of the insect giants had already begun. Imagine standing in the heart of a carboniferous forest. The air feels thick, damp, and almost electric, so rich with oxygen that every breath burns faintly sweet. The ground squelches beneath your feet, and the canopy above blocks most of the sunlight. Towering trees rise like pillars in a green cathedral, their roots tangled in pools of black water. A sudden flutter cuts through the stillness, not the fragile flutter of a butterfly, but the heavy, rhythmic beat of wings strong enough to stir the air around you. A giant dragonfly glides past, its body shimmering like metal, its eyes reflecting the forest like twin mirrors. It hovers, silent for a moment, then dives toward a smaller insect. There's a flash, a soundless strike, and the prey is gone. This was the world of Meganeura, the first true aerial predator in Earth's history. Its eyes contained thousands of lenses, granting a near-perfect panoramic view. Its wings, controlled by intricate muscles, allowed it to hover, dart, and even fly backward, feats unmatched for hundreds of millions of years. Its nervous system was tuned to speed and precision, making it a living machine of flight and hunger. But how did these creatures become so large, and why can't they exist today? The answer begins with the invisible world inside their bodies. Unlike vertebrates, insects don't have lungs or blood that carries oxygen. Instead, air travels directly through a network of tubes, tracheae, branching into every corner of their bodies. This system works beautifully when the insect is small. But as body size increases, diffusion becomes harder. Oxygen struggles to reach deeper tissues. In the Carboniferous, this limit vanished. With oxygen levels soaring to 35%, insects could grow larger while still delivering enough oxygen to every cell. The planet's atmosphere itself was their superpower. But oxygen wasn't the only factor. The Carboniferous landscape was also a vast greenhouse of opportunity. The absence of flying vertebrates meant no competition in the skies. Early amphibians and primitive reptiles were slow and mostly bound to the ground. Insects faced no predators from above. They were the hunters. Meganeura's prey was likely smaller flying insects, mayflies, early cockroach-like species, and larvae emerging from stagnant waters. Fossilized plant resin and shale deposits reveal impressions of their delicate wings, sometimes preserved mid-beat, like frozen echoes of movement. One particularly striking fossil found near Commentry, France, shows Meganeura's wings spread perfectly, the veins etched in stone like ancient circuitry. Each vein carried strength, flexibility, and air, a design both functional and artistic, crafted by evolution itself. In this era, the skies weren't just filled with dragonflies. They were alive with strange, alien forms, early lacewings, primitive beetles, and massive cockroach-like insects that buzzed between giant club moss trunks. The air would hum constantly with movement, a living orchestra of wings. On the ground, Arthropleura crawled through the leaf litter, its dozens of legs clicking against decaying wood. Some scientists believe these massive millipedes could rear up when threatened, towering over small amphibians. Their armor-like plates gleamed in the humid light, and their bodies moved in hypnotic waves. Predators like Pulmonoscorpius patrolled the shadows, hunting both above and below water. Fossil evidence suggests these ancient scorpions had primitive lungs, an evolutionary bridge between water and land. They might have hidden under tree roots, waiting for prey to stray too close. Every corner of this world teemed with colossal life, each form an adaptation to a planet breathing harder than it ever would again. And yet, there was balance. The dense forests consumed vast amounts of carbon dioxide, while the burial of dead plant matter created oxygen surpluses. Nature had built a perfect atmospheric machine, but it was unstable, fragile. One small shift, one geological tremor, and the balance would falter. The great insects didn't know it, but the clock had already started ticking. Deep within the swamps, unseen by any compound eye, Earth was changing, continents were colliding, temperatures shifting, and the oxygen-rich paradise that had birthed the Sky Kings was beginning to crumble. When that balance broke, the world that sustained them would vanish, and so would the giants of the air. As the Carboniferous period drew to a close, the planet began to shift beneath the feet and wings of its inhabitants. The lush tropical swamps started to dry. Vast forests, once dense with oxygen-producing vegetation, began to collapse. The Earth was preparing for a new era, the Permian, a time of continental unification, violent climate swings, and thinning air. What had been a paradise for giant insects slowly turned into a world that no longer favored them. Scientists believe that the downfall of the insect giants can be traced to two invisible assassins: a changing atmosphere and new predators. The first was oxygen itself, the very element that had created their empire. As swamp plants died off and carbon became locked underground in vast coal beds, the oxygen levels of Earth began to plummet. What had once been 35% fell closer to 21%, the same as today. To us, that sounds normal. But for a creature that depends on pure diffusion to breathe, it was a catastrophe. Large insects suffocated. Their tracheal systems, once efficient highways for oxygen, could no longer deliver enough air to sustain such massive bodies. The giants dwindled, and smaller, more efficient species began to dominate. Evolution favored the compact, the adaptable, the ones that could live on less. The second killer was competition, the arrival of vertebrate flyers. By the late Permian and early Triassic, early reptiles had begun experimenting with new body plans. Some would eventually evolve into the first true flyers, the pterosaurs. These creatures, with skeletons of bone and muscle, could grow large without the limitations of an insect's exoskeleton. They breathed with lungs, powered by active circulation, a major evolutionary advantage. For the first time in Earth's history, the skies were contested. The insect kingdom, once unrivaled, now faced agile predators that could outfly and outlast them. Fossil evidence shows a dramatic reduction in insect size during this transition, suggesting not just environmental stress, but also the pressure of predation. It wasn't just the giants that suffered. The entire structure of Carboniferous ecosystems collapsed. The dense forests dried into open plains. Massive fires swept through oxygen-rich woodlands, devastating insect populations. Rivers changed course, climates cooled, and entire food webs vanished. The great dragonfly emperors, once symbols of evolutionary triumph, disappeared, leaving only smaller descendants to carry on their legacy. And yet, their story didn't end in extinction. The dragonflies that still glide over modern ponds, Anax imperator, Aeshna juncea, and others, are echoes of that prehistoric glory. They retain the same wing design, the same hunting reflexes, the same eyes made of 1,000 lenses. Every time a dragonfly hovers effortlessly over still water, we're witnessing a living fossil, a direct descendant of the first conquerors of the air. But their fall also opened the way for new forms of life. The decline of the giant insects cleared the skies for vertebrate flyers. First pterosaurs, then birds, and much later, bats. The same evolutionary stage that had once belonged to chitin and compound eyes now belonged to feathers, bones, and warm blood. Still, the mystery lingers. Was oxygen the only factor that shaped this transformation? Some scientists suggest that changes in atmospheric pressure and temperature also played a role. Others point to the emergence of new plants, which altered the chemical makeup of the air. There are even theories that giant insects were limited not just by oxygen, but by gravity, that their flight structures could not sustain the same lift as the planet's density changed. And yet, for all the data, the fossils, and the equations, one question remains unanswered. Why did they never return? After all, Earth's oxygen levels have fluctuated throughout history. At times, they've risen high enough that large arthropods could have evolved again. But perhaps evolution had already chosen a new path. Once vertebrates mastered the skies, nature didn't need to repeat herself. The age of giant insects became a forgotten chapter, a strange prelude to all the flight that would follow. Today, scientists study their fossils not just to understand how they lived, but to imagine what life could look like under different atmospheric rules. What if the Earth's oxygen rose again to ancient levels? What if the balance tipped once more toward excess? Would we see new giants, insects large enough to cast shadows over our cities? Theoretically, yes, the laws of biology would allow it. But our modern world is filled with predators and competition unlike anything the Carboniferous ever knew. The reign of insects, once absolute, would face the machines, lights, and poisons of humanity itself. Perhaps the age of monsters has passed, not because the planet can't make them, but because the planet now belongs to something else. And yet, in the fossil record, in the fragile outline of a dragonfly's wing pressed into stone, we can still glimpse that lost dominion. A world where the air itself made titans. A world where the first flight was not graceful or feathery, but hard, humming, and alive. When we look back at the age of giant insects, we're not just studying fossils, we're peering into the blueprint of life itself. The story of Meganeura and its kind isn't just about what once was, it's about what still could be. Because what made them rise and what caused them to fall are the same forces that still shape us today. The air we breathe, the balance we live within, and the fragility of our world's invisible systems. The Earth of the Carboniferous was a living machine, vast forests pumping oxygen, ecosystems recycling every breath. It was balanced so precisely that even the smallest change could rewrite evolution's script. When that balance broke, the age of insects ended. Now, millions of years later, humans have taken the stage, not as insects, not as passengers of the planet's chemistry, but as its engineers. We've learned to change the air itself, to raise temperatures, to alter gases, to carve the land and sea to our will. We've become, in a way, the new architects of the atmosphere. But here's the unsettling truth. The insects didn't know their empire was ending until it already had. They lived as they always had, hunting, breathing, surviving, unaware that their oxygen-rich paradise was fading with every passing century. And aren't we the same? We build our civilizations under skies we assume will always stay blue, under climates we assume will always feed us. Yet Earth's history whispers otherwise. Every empire of life, from giant insects to dinosaurs, from mammoths to men, lives at the mercy of the planet's breath. The insect's story reminds us that power is always conditional. Their dominance wasn't eternal. It was environmental. They ruled not because they were the smartest, but because the planet allowed them to be. In that way, they are a mirror to us. Human civilization thrives under a narrow window of conditions, a thin band of temperature, oxygen, and chemistry that makes our existence possible. If that window shifts, even slightly, the outcome can be catastrophic. But beyond warning, there's also wonder. The story of prehistoric insects is a celebration of adaptation. Even after their giants fell, insects survived. They reshaped themselves, smaller, lighter, faster, until they became one of the most successful groups of life in history. They've outlived nearly every mass extinction, from the Permian apocalypse to the fall of the dinosaurs. Think about that. Every buzzing fly, every flickering firefly, every dragonfly gliding across a pond, all are survivors of cataclysms that wiped out most of Earth's species. Their ancestors once filled the skies with wings as wide as eagles, but when the air changed, they didn't disappear. They adapted. That's their true legacy. Not size, not power, but resilience. And perhaps that's the lesson we're meant to take from them. That survival belongs not to the strongest or the largest, but to those who can change, who can shrink, evolve, transform when the world demands it. Insects remind us that dominance is fleeting, but persistence, that quiet, relentless will to continue, can outlast even extinction itself. Maybe that's what connects us to them. Because in a way, humanity is still learning how to fly, not with wings of chitin, but with machines of metal. We've taken to the skies they once ruled, and yet, for all our technology, the same ancient rule applies. The air decides. If it changes, everything changes. So the next time you see a dragonfly hovering effortlessly in the sunlight, remember, it's not just an insect. It's a message, a living relic of an age when air itself could give birth to giants, and when every breath carried both life and danger. It survived what giants could not. And if we wish to endure the ages as they did, perhaps we too must learn to adapt before the air around us changes again. The story of the prehistoric insects that ruled the skies is more than an ancient curiosity. It's a testament to the shifting power of life on Earth. 300 million years ago, when the air was thick with oxygen and the forests glowed with endless green, the world belonged not to mammals or reptiles, but to creatures of delicate wings and armored shells. Meganeura, Arthropleura, Pulmonoscorpius. Their names now sound like myths, yet they were real, alive, and dominant. They remind us that power can take unexpected forms. The first lords of the sky were not predators of bone and muscle, but of chitin and air. Their world was vast, alien, and yet profoundly fragile. As the air changed, their empire dissolved. As the oxygen fell, the giants vanished. And from their extinction came the seeds of everything that would follow: reptiles, birds, mammals, and eventually, us. Their rise and fall are written in the stone beneath our feet. Every fossilized wing, every impression of a compound eye, is a page in Earth's oldest book, a book that keeps rewriting itself through fire, flood, and time. When we read that book, we aren't just learning about the past. We're glimpsing the rhythm of the planet, a rhythm that humankind has now begun to alter. The same invisible breath that gave life to giant insects is the breath we still share. And just as it sustained them, it can just as easily turn against us. The age of insects was a chapter that ended quietly, without warning. No sudden disaster, no meteor, no single extinction event. Just a gradual shift, an invisible imbalance, and then silence. Perhaps that is the most haunting part of their story. Not their size, not their power, but their fragility. They ruled the world until the world itself changed the rules. And so, as we continue to explore the deep past through fossils, science, and imagination, we are really exploring the limits of our own existence. How far can life stretch before it breaks? How long can any species rule before the balance tilts? The answer lies not just in the rocks, but in the air we breathe, the same ancient air that once fueled wings large enough to block the sun. So the next time you watch a dragonfly hover effortlessly in a ray of light, remember, you are seeing an echo of a vanished world, a survivor of a lost empire, a creature that once ruled the skies long before humanity could even dream of flight. And ask yourself, if life could make giants once, what else might it create again? Because in the grand story of evolution, nothing is ever truly gone. It only waits, in silence, in stone, in the breath of the earth, to rise again. Narrator, final tone, soft and reflective. Thank you for joining this journey into the forgotten age of flight. If you believe the past still has secrets to tell, like, subscribe, and stay with us as we uncover the next chapter in humanity's search for its ancient origins. Because this is only the beginning.